We are here again with another video offered to you by the Ceuster Academy. When you're here for the first time, do not forget to subscribe. When you're already subscribed, I hope you will like the movie and that you will share it with others. For the new people, don't forget to click on the bell too, because then you will be informed when we have a new video for you. In this series about finance, and we are talking about the time value of money, we looked already at the principles of interest rate, the simple interest rate, the compounded interest rate, and we also considered different compounding periods. Now, when we did a simple calculation of the compounded interest after 1 year, we saw when we started with an interest of, for example, 5%, that after compounding daily over 1 year, we found a slightly increase of that percentage. Now, when I took my first mortgage, they used the calculation, I got 9% monthly payments, so they divided 9 by 12%, but the law in Belgium in that case changed in the sense that we have to show, or that the people who sign a loan have to know what is the effective annual rate, what is the real interest rate over 1 year. And in order to be able to do that, we have to define what is the effective annual rate, and we have to find some formulas how to calculate it. It's a very important element to understand what's the effective annual rate, because basically all our investments we compare with typically an annual rate. Now, the formulas are not so difficult, but we have to take into account that there are some calculations to be conducted. And when we look at the calculation and the formulas, we first have to look at the compounding formula. And when we look at the compounding formula, we can say that basically the principal multiplied with the interest, 1 plus the interest rate, is equal to the compounded value. So when we take a compounding, for example, over a period, whatever the period is, I call it PER, period, then the periodical interest, the compounding interest that we are going to use is the yearly interest divided by the number of periods. And when we compound over 1 year, we find that the principal compounded periodically over 1 year is P multiplied with 1 plus the periodical interest rate to the power of the periods. So when we compound monthly, we have to define or divide the yearly interest rate by 12, and we have to compound 12 periods. It means that the principal multiplied by 1 plus the effective annual rate, the real interest rate we are paying over 1 year, is equal to the compounded value. And since we have the principal in both sides, we can divide both sides, and we find a simple formula, which is 1 plus the effective annual rate is equal to 1 plus the yearly rate divided by the periods to the power of the periods. And the one thing that remains is bring the 1 to the other side, and we find that the effective annual rate is the compounded interest over the periods minus 1. And we can calculate this for all different kind of compounding periods. Here we have a table. We look at 5%. 5% is the yearly interest rate, and we look at the different periods. We look at the periodical interest. We look at the formula, and finally we calculate the equivalent annual rate. For a year, okay, we don't have to calculate it because it's 5%. The compounding period or the compounding interest is 5, so it remains 5%. There is only 1 period to compound. Now when we look at the quarterly compounding, we find that the quarterly interest rate is 5 divided by 4. It's 1.25%. And the formula of the equivalent actual rate for a quarterly compounding is 1 plus the quarterly interest to the 4th power minus 1, which gives us 5.0945%. We see there is a small increase of the interest rate. When we look at the monthly interest rate or the monthly compounding, we see that the monthly interest rate is 5 divided by 12, and we find that the equivalent annual or the effective annual rate is 1 plus the monthly interest rate to the power of 12 minus 1, which gives us approximately 5.1162%. Of course, there are more decimals, but we are limited a little bit, or limiting them because they don't have the necessary significance. We can look at a weekly compounding. Weekly compounding makes us divide the 5% by 52. We use that interest rate to calculate the effective annual rate, which is again 1 plus the weekly interest rate to the power of 52 minus 1, which gives us 5.1246%. And the last one is the daily compounding, and that's the calculation we did at the end of the previous presentation. We find that the periodical interest rate is 5 divided by 365, and when we put it in the compounding formula, in the effective annual rate formula, we find that we have 1 plus the daily interest rate to the power of 365, 1 complete year, minus 1, and it gives us 5.1268%. So these are the different examples that we have when we have that calculation. And when we look at the formulas, when we look at the different steps, when we want to know what is the periodic interest rate when we start from the effective annual rate, so it's the inverse calculation. Now we say we want to have a yearly interest rate of a certain value. We do compounding over, let's say, 12 months, compounding per month. Then we have to be able to calculate the effective annual rate. Now we start from the formula that the effective annual rate is 1 plus the periodical interest rate to the power of the periods minus 1. So we bring the 1 again to the other direction. We find the equivalent annual rate plus 1 is equal to the compounded interest. And now we take the root. We take the root, the nth root, n equal to the period of the equivalent annual rate plus 1. And we find that now we have on the other side, on the right-hand side, 1 plus the periodic interest rate. And basically, we can deduct from this immediately the periodic interest rate, which is equal to the nth root, n equal to the period of the equivalent or the effective annual rate plus 1 minus 1. So this is the inverse combination, the inverse calculation. When we want to have an effective annual rate that is predefined, we are compounding monthly, so we can now calculate the monthly interest rate that we have to apply. You see, there are a lot of things that are possible when you understand this and you're talking with finance people. You will understand the secrets of interest calculations, and when you understand this, you will be able to talk, for example, to your bank manager on a different level, because sometimes when those people are talking to you, they want to show how good they are, they show their knowledge, and you may be a little bit intimidated, but basically, if you understand this, you can understand them a lot better, and you're talking into with them on a different level, and you will see that they will react differently. This is another interesting video. We finished it. We have more videos to come, so when you like the topics, when you like our presentations and videos related to project management, business, earned value and other topics, like our videos. Do not forget to subscribe, share it with your friends and peers and colleagues and people. Just come back, have another look at some other of our videos, and of course we will be happy to answer your questions. Do not forget to subscribe. I'm repeating it again, but I'm sure I will see you in our next video. Thank you and bye-bye.